This is lesson 4.1, solving linear inequalities. Today's objective is that you will be able to solve a linear inequality when it's all said and done. So let's quickly review. Before we jump into inequalities, let's talk about equations. What makes an equation an equation? So if you look at an equation and you describe that to me as an equation, how do you know it's an equation? Well, hopefully it's that equal sign. An equation contains an equal sign. If you see an expression and it does not have an equal sign in it, it is not an equation. How many solutions does an equation have? So we've been solving equations the last couple days, and when you go through all that solving, you end up with x equals 5. How many solutions do you get? Well, except for the special cases that we talked about yesterday, typically you only have one solution. Now, there are some cases we saw yesterday where you may have no solution, or you may have all real numbers, so infinitely many solutions. Those are very rare, and that's why they're called special cases. Most equations have one solution, and one solution only. So let's quickly review. Look at the following 5 symbols and see if you can remember what they stand for. This first one, we refer to that as a less than symbol. It is strictly less than. The second symbol, we refer to that symbol as strictly greater than. These next 2 symbols, notice how they have the equal sign bar. That's important. That denotes that they are less than or equal to, or greater than or equal to. Less than or equal to and strictly less than mean 2 very different things. Same thing with greater, strictly greater than, and then greater than or equal to. They mean 2 very different things. And this last symbol you may or may not have seen before. That's just a not equal to sign. Okay? Those 5 symbols above represent what we call inequalities. So anytime you see an expression and it contains a less than sign or a not equal to sign, that is not an equation, that's an inequality. Okay? Inequalities are very similar to equations. They solve just like equations do. We can solve them just like we've been doing with equations. That's why we moved this lesson up to chapter 1. However, there are a couple differences. As we said earlier, a linear equation typically has one solution. Only one number will satisfy the equation to make the equation true. And you guys can attest to that. When you guys check your answers, you know that there's only one number that when you plug in is going to make 9 equal 9. That kind of a thing. When we talk about inequalities, it's a little bit different of a situation. Linear inequalities have what we call a solution set. So instead of there just being one number that can satisfy the inequality to make the inequality true, there are many numbers that can satisfy the linear inequality to make the inequality true. And here's some examples of what I'm talking about. For instance, the first inequality here, we have x is greater than 4. Take a second to think about a value that would satisfy that. We just need a number to be greater than 4. There's lots of values that are greater than 4. 5 is greater than 4. 6 is greater than 4. 20 is greater than 4. 900 is greater than 4. 2 billion is greater than 4. You can see how there's many numbers that will satisfy the situation. Look at the second one. X is less than or equal to 2. Okay, well, what are some numbers that are less than or equal to 2? Well, 2 will work. 1 will work. 0, -5, -20, -6 million, -3,000. All numbers that will satisfy that inequality. And how about the last one? Well, the last one, there's tons of numbers that'll work for it. If x cannot equal -496, what can x equal? X can equal any number in the world as long as it's not -496. So you can see where it's not as simple as saying x equals 2, done. We have to figure out a way that whenever we solve and we find that x is less than or equal to 2, how do we get the point across that of how many numbers satisfy that equation, or that inequality, I'm sorry. So how do we represent all those possible values? Well, we must graph our solutions on a number line. So this is not graphing using slope and all that fun stuff. This is just simply drawing a number line, plotting numbers, and shading accordingly. Now when we draw this number line, there are a couple guidelines we have to follow when we try to plot our solution. The first piece of information we have to consider is the type of circle. If the inequality sign that is in your inequality is a less than or equal to, or a greater than or equal to symbol, you're going to use a closed circle. This simply represents that the value is included in the solution. Okay, that value will make the inequality true. If you have a less than symbol, a greater than symbol, or a not equal to symbol, you're going to use an open circle. This just denotes that open circle denotes that value is not included in the solution set. It can get really, really close to that value, but it cannot be that value because it'll make the inequality not true. Second piece of information we have to consider is which direction to shade. If you see a less than or equal to symbol, you're going to shade left. That just goes back to number line sense. If you plot your values in numerical order on the number line, and you're telling me that x is less than 2, numbers to the left of 2 will be numbers that are less than 2, so you'll shade to the left. If you have a greater than or equal to symbol, once again, goes back to number line sense. As long as you write your numbers in numerical order on the number line, plot your point, or plot the value that x is greater than, shade to the right, because values to the right will be greater than the value you plotted. Now if you have the not equal to symbol, you're going to use the open circle as we discussed over here. Remember we said in the previous slide that if x cannot equal negative 496, that means it can't equal negative 496, but it can equal any other number in the world. So you're just going to simply draw an open circle on negative 496 and then shade both directions on the number line, because it can be any value in the world as long as it's not the value that has the open circle. So you'll just shade in both directions. Alright, so solving linear inequalities. As I said before, solving linear inequalities solve just like equations. You follow the same steps, the same rules apply. However, there is one golden rule that you have to be aware of. And this is very important. I want to make sure that it is carved into that brain of yours because you cannot forget this. It's a huge rule. If you are solving a linear inequality and you multiply or divide by a negative at any point when solving, you must flip the inequality sign. Okay? So if you have a less than symbol, it'll be flipped to a greater than symbol. If you have a greater than or equal to symbol, it'll be flipped to a less than or equal to symbol. So let's try an example. We want to solve the inequality and check our solution. So as you can see, the setup is very similar to that of an equation. The only difference is instead of having an equal sign, we have a less than symbol. So if this was an equation, we would start by simplifying. Is there anything we can simplify? No, I can't combine any like terms here. I can't distribute. There's nothing to be distributed. So I'm set up for solving. So now I just need to follow my order of operations in reverse. So I see subtraction happening right here. So I'm going to start by adding 15 to both sides. Negative 15 plus 15 is 0, so you're left with 5x. Make sure you bring down the less than symbol. It sounds silly, but that's something that a lot of students, even teachers, you'll get in the habit of writing those equal signs because that's just what you're used to writing. It just feels natural. Make sure you don't drop off the inequality sign. Make sure you keep it as is. And then negative 45 plus 15 is negative 30. Okay? We have 5 times x is less than negative 30. So we got to get x by itself. 5 is being multiplied to x, so to move it we need to divide by 5. Okay? 5 divided by 5 is just 1. Negative 30 divided by 5 is negative 6. Now, as far as this golden rule goes, if I would have divided by a negative 5 right here, then I would have needed to flip my sign. Since it's not negative, I don't need to flip my sign. It's perfectly fine for your answer to be negative. If your answer is negative, that's all fine and dandy. You do not need to flip the sign. If you multiply or divide by a negative, so this step right here, if you catch yourself multiplying or dividing by a negative number, then the sign needs to change. Okay, so part of our answer is x is less than negative 6. Now we need to represent all the values that x can be. So your options here are to write out a bajillion numbers, or we can do the number line, which is what we're going to do. So the number line is part of your solution. It is not an option. You must graph your solution on a number line to represent all of the values that x can be. So I'm going to start by plotting negative 6. If you need to refer back to the previous slides to recall your graphing rules, the open, close circle, and shading, take a second to do that. You can pause the video. If you look at the inequality sign, it's less than. So because it does not have an equal sign on it, we're going to have an open circle. X is less than negative 6. So any number that is smaller than negative 6 is our solution. So we're shading to the left. Now we want to check our solution. So you want to pick something in the shaded region. Now that's the beauty of this. I picked negative 8. Would you be wrong if you picked negative 7? Absolutely not. Could you pick negative 10? You bet. Could you pick negative 20? Yeah. Anything that is going to be less than negative 6 you can pick. However, because we have this open circle here, you cannot use negative 6. That's a hole. That's saying that it's going to get really, really, really close to negative 6, but x cannot be negative 6. If you choose negative 6 when you plug in, you're going to get an inequality that is not true. So I'm going to use negative 8. If you want to use another number, feel free to. So all I'm going to do is replace x with negative 8, just like I did here. 5 times negative 8 is negative 40. Negative 40 minus 15 is negative 55. So now you need to ask yourself, is negative 55 smaller than negative 45? And it is. That's a true statement. So this is correct. That is our final answer. Here's another example. We want to solve and then check our solution. So let's think about our solving rules again. First thing you want to do is simplify. Well, looking at the left-hand side, I don't have any like terms. Nothing can be distributed. This is a division bar, but it's not the big division bar that would cover the entire problem. It's just a small one, so we're good to go. Let's start doing our order of operations in reverse. I'm going to start by adding 6 to both sides. Negative 6 plus 6 is 0, so I'm left with y over negative 2. Make sure you bring down the inequality sign. Negative 1 plus 6 is 5. Now I need to get y by itself. Y is being divided by negative 2. So to undo that division, I need to multiply negative 2 to both sides. Now here's your golden rule at play. You multiplied by a negative number, so we have to flip the sign when we go to write our next step. Negative 2 divided by negative 2 is just 1, so I'm left with y. My greater than sign becomes less than or equal to because I flipped the sign. I divided by a negative. And then 5 times negative 2 is negative 10. Okay, so this is part of the answer, but remember we have to represent all of the possible solutions, so we're going to graph our solution on a number line. So to start drawing your number line, go ahead and plot the value, -10. And now we need to think about our number line rules. We have an equal sign on the inequality, so I'm going to have a closed circle. So -10 is part of the solution. When we go to check our answer, if you want to pick -10, it's okay to do so because it's closed. It's part of the solution. It says y is less than or equal to -10. So anything smaller than -10 gets shaded, so that just means shade left. Okay? Make sure you always want to graph the inequality as it ends. Don't graph the inequality from the beginning of the problem, because if you do flip, you need to reflect that flip on your number line. So now we need to check our answer. So once again, feel free to pick any value that's in this gold area. Okay, you can pick -10. I'm going to pick -16. So here we go. Does it work? I'm going to replace y with -16. -16 divided by -2 is just 8. 8 minus 6 is 2. Is 2 greater than or equal to -1? You bet. So that is my final answer. Alright, so go ahead and take a second to pause the video and try these two problems out. Make sure you understand your answers. Make sure you understand how to represent all your solutions before you move on. If you have any questions, make a note of it and come talk to me in class. These are the answers that you should get. Let's try another one. Solve and check your solution. So I have 1/4 times -8x plus 8 is less than or equal to 2x plus 2. So I'm going to start by distributing. I see parentheses, so I'm going to distribute. 1/4 times -8 is -2x. 1/4 times a positive 8 is just a positive 2. Okay? So this is actually a problem that has variables on both sides. So this problem is going to be similar to the problems we talked about yesterday with equations, except now we have an inequality sign. So our goal is going to be to get the variables to one side. So I'm going to move this 2x. 2x minus 2x is just 0. -2x minus 2x is -4x. And bring everything else down. So now my variables are together, so I'm going to start solving for x. I need to undo any addition or subtraction, so I'm going to subtract over the 2. Then divide by -4. And I have x is less than or equal to 0. Okay? Remember, that's part of your solution. So now you need to graph it on a number line. So draw your number line. Plot 0. I have an equal sign on the inequality, so I'm going to use a closed circle. X is less than or equal to 0, so I'm shading left. Now I'm going to check my solution. -1 falls in that gold region, so I'm going to plug that in for x. I replaced x with -1. And now I'm just going to use the order of operations to simplify down and make sure that this inequality does make sense. -8 times -1 is just 8. 2 times -1 is -2. 8 plus 8 is 16. -2 plus 2 is 0. 16 times 1/4 is 4. So now ask yourself, is 4 less than or equal to 0? Is that a true statement? That is a big fat false statement. That is not true. 4 will never be smaller than 0. So now we have a false statement. So you need to go back, pause the video, take a second to figure out where we went wrong. What did we do wrong in this problem? Take as long as you need. Make sure you can analyze this problem and figure out why it's wrong. So hopefully after looking through the problem, you notice that on this step right here, we divided by -4, but we forgot to change our sign. So instead of saying x is less than or equal to 0, should be x is greater than or equal to 0. So our shading is off. Instead of shading to the left, we actually need to shade to the right. So you can see where forgetting to flip the sign will cause your answer to be completely wrong. You will shade the wrong values, the complete opposite values that you should be shading. So make sure you check your work. Always, always, if you multiply or divide by a negative, make sure you flip the sign. Alright, so did you meet the objective? Time for you to prove it to me. You should be able to solve linear inequalities after going through this lesson. So I have these 2 problems for you to try on your own. These are the answers you should get. If you have any questions, make sure you make arrangements to see me before or after school for further help. You can always try to rewatch the video. If you need more practice problems, feel free to talk with me.